The record begins as an anomaly in background measurements, the kind that is usually filtered out before human review. A deviation small enough to be ignored, yet coherent enough to survive automated correction. The facility was designed to observe nothing in particular, only to confirm that nothing behaved as expected. In that sense, the system functioned perfectly. What emerged did not announce itself through energy spikes or catastrophic signatures, but through absence, subtraction, a quiet removal of assumptions. At first, the discrepancy appeared in synchronized atomic clocks distributed across a controlled region. They disagreed. Not in the relativistic way predicted by velocity or gravity, but in a fragmented manner, as if time had lost its continuity and reassembled incorrectly. The offsets did not scale. They formed clusters, plateaus, abrupt discontinuities. Internal diagnostics reported no fault. Environmental conditions were stable. Redundancy confirmed consistency. The disagreement was real. Simultaneously, gravimetric sensors recorded oscillations in local curvature without corresponding mass energy input. The equations produced values that canceled themselves. Negative curvature without repulsion. Density without inertia. Lensing without a source. Optical interferometers failed to detect a surface. Yet light passing through the region bent inward, converging on a volume that did not scatter, absorb, or emit. It behaved as a boundary defined not by matter, but by restriction. The data suggested something occupying space without occupying space-time in the usual sense. Vacuum fluctuation probes registered a sudden suppression of zero-point energy. This was not a fluctuation, but a sustained condition lasting fractions of a second. The vacuum behaved as though depleted, yet no compensatory radiation followed. Energy was not transferred. It was removed from accounting. Entropy calculations collapsed. Systems inside the region exhibited increased order without work. Correlations strengthened spontaneously. Probability distributions narrowed. Randomness retreated. The phenomenon did not generate heat. It did not cool. Temperature ceased to be a meaningful variable within the detected boundary. Attempts to visualize the event required abandoning conventional rendering. When mapped, the region appeared as a volume of exclusion, a geometric refusal. Edges were sharply defined but mathematically unstable, their dimensionality fluctuating between integer and fractional values. At moments, cross-sections implied more volume internally than externally permitted. Topology inverted briefly, then corrected. Spatial metrics disagreed on distance. Some paths shortened when measured repeatedly, others lengthened without motion. The duration of the event depended entirely on the observer's frame. Yet even after correcting for relativistic effects, no invariant interval could be extracted. Some clocks recorded the phenomenon before it occurred. Others continued registering its presence after all sensors agreed it had ended. Causality diagrams tangled. Cause and effect overlapped. Data points appeared without precursors. Statistical analysis revealed traces of influence extending backward along the timeline, subtle but persistent. What distinguished this anomaly from prior unexplained events was not magnitude, but coherence. It behaved consistently across domains that should not correlate. Quantum measurements aligned with classical sensors. Noise decreased as signal complexity increased. The region resisted perturbation. When probed indirectly through increased observation density, the anomaly adapted, reducing measurable interaction while preserving internal consistency. This behavior prompted the first internal use of biological terminology, not publicly, not philosophically, but pragmatically. The system exhibited bounded persistence, self-limitation, and selective interaction. These properties satisfied the minimal operational definition of a creature, stripped of intention or consciousness, reduced to functional autonomy. Subsequent reanalysis of archival data uncovered weaker precedents. Similar signatures appeared scattered across decades of measurements. always dismissed as instrumental artifacts. None lasted as long. None displayed the same multi-domain alignment. The recorded event represented an amplification, a threshold crossing. It suggested not emergence, but arrival. The most troubling implication arose from conservation analysis. The anomaly did not violate physical laws by opposing them. It bypassed them. Conservation laws were not broken. They were rendered irrelevant within the boundary. Equations returned undefined, not because parameters diverged, but because the underlying assumptions no longer applied. The phenomenon operated in a regime orthogonal to established physics, intersecting it briefly without conforming. After the collapse of the region, no debris remained, no radiation spike, no residual field. Only a statistical scar persisted, detectable through long-term analysis of subsequent experiments. Measurement noise exhibited asymmetry. Certain outcomes became marginally more likely, others less so, without causal explanation. Reality appeared slightly biased, as though a rule had been nudged. This residual effect could not be localized. It was not a field. It did not decay. It manifested only through aggregation. Individual experiments revealed nothing. Large datasets betrayed it. The probability landscape had been altered, subtly reshaped. The question arose whether the recorded event was singular or merely visible. Whether it had always existed, moving through observational blind spots, or whether conditions had finally aligned to allow detection. No evidence supported creation. All evidence suggested intersection. The creature, if the term is permitted, did not leave. It withdrew, and the laws of physics, unchanged on paper, no longer appeared complete. The immediate response was not excitement but containment, because the most unsettling property of the recording was its compatibility with ordinary instrumentation. It did not require exotic detectors to notice. It required patience, redundancy, and an environment quiet enough to allow a nearly silent exception to stand out. The anomaly had been recorded not by a single instrument, but by an ecosystem of measurement, each device confirming a different facet of the same refusal. The first priority became verification through reconstruction. The second priority became replication without escalation. Both priorities failed in ways that revealed more than success would have. Replication attempts began with the only reasonable approach: to recreate the boundary conditions that existed during the event. This required reconstructing electromagnetic background levels, atmospheric density profiles, local seismic micronoise, cosmic ray flux, and the thermal stability of instrument housings down to negligible gradients. None of these variables appeared decisive, yet the anomaly had coincided with an improbable alignment across them. Every subsequent attempt reproduced almost everything except the phenomenon itself. The instruments behaved beautifully. The clocks stayed aligned. The vacuum probes reported normal fluctuations. The interferometers returned clean interference fringes. Nothing happened, and that absence initially appeared reassuring. The reassurance eroded when meta-analysis compared the replication windows to the original. A pattern emerged, not in what was present, but in what was missing. The original dataset contained a subtle prelude, a progressive tightening of randomness across multiple channels, as if the environment had been quietly conditioned. Before timestamp 0, background noise had narrowed, not reduced in amplitude, but reduced in unpredictability. The spectrum of fluctuations looked normal, yet its phase relationships became unusually consistent. Independent noise sources began to exhibit weak mutual information. The world, for a brief interval, had become slightly too coordinated. This prelude was difficult to explain away as coincidence. In a system engineered to isolate signals from noise, the noise itself had aligned. When the anomaly appeared, it did not interrupt the prelude. It completed it. The phenomenon seemed less like an intrusion and more like a state transition, a phase change in the informational structure of the region. In the following weeks, Two parallel investigative threads formed. One focused on physical hypotheses, attempting to preserve existing laws by adding new entities or regimes. The other focused on measurement theory, suspecting the anomaly might exploit the act of observation itself. Both threads encountered the same wall. The recordings behaved as though they contained a contradiction that could not be localized to any single assumption. Physical hypotheses proliferated. Negative mass bubbles, localized wormhole throats, false vacuum decay arrested mid-transition, quantum gravity microstructure surfacing at macroscopic scale, exotic matter stabilized by unknown interactions. Each hypothesis could match a subset of signals, yet each failed catastrophically when confronted with the full dataset. Models that explained the lensing could not explain the clock fragmentation. Models that reproduced vacuum suppression produced radiation that was not observed. Models that maintained energy conservation could not account for entropy behavior. The dataset behaved like a lock that accepted no key. Measurement theoretic approaches fared no better. If observation collapsed something into existence, then increasing observational intensity should amplify the effect. But when observation density was increased, the prelude did not strengthen. It weakened. When sensors were added, the system became less likely to exhibit correlated noise tightening. When redundancy increased beyond a certain threshold, the environment returned to ordinary randomness faster, as though the experimental configuration itself discouraged the conditions that preceded the anomaly. This was the first indication that the phenomenon might treat measurement not as passive recording, but as an environmental factor, a variable to be navigated. The recorded event had occurred during a low attention period, when the array was stable and unmodified, operating in a quiet equilibrium. Replication attempts introduced intention through configuration changes, schedule adjustments, and heightened monitoring. The system, in becoming more watchful, may have changed the world it wished to watch. A second verification pathway was pursued, mining global archives for similar signatures. If the creature had intersected once, it might have intersected elsewhere. The search was not for identical events, but for the prelude, the improbable tightening of noise, and the multi-domain phase alignment. Vast repositories were scanned, including gravimetric baselines, atomic clock networks, neutrino observatories, deep space communication timing logs, and interferometric strain records. The results were sparse, but not empty. Several candidate intervals emerged across years and continents, all previously categorized as sensor drift or environmental interference. When these candidates were reprocessed with the new pattern in mind, a consistent motif appeared. The prelude preceded each candidate. In some cases, it lasted milliseconds, in others, tens of seconds. In each case, it ended abruptly, either returning to normal or breaking into data artifacts that had been dismissed. Only one candidate displayed a full transition resembling the primary event, and even that was weaker, shorter, less coherent, more ambiguous. Yet it shared the same structural fingerprint. A bounded region of statistical order embedded in ordinary noise. This suggested an uncomfortable possibility. The phenomenon might not be rare, only rarely visible as coherent. Most intersections might be partial, clipped by environmental complexity, drowned by noise, or prevented by observational interference. The recorded event was not necessarily unique, it was unusually legible. A new strategy emerged. Rather than recreating the original physical conditions, recreate the original informational conditions. Instead of manipulating fields and temperatures, manipulate the unpredictability landscape. Introduce controlled stochastic processes. Adjust correlations between independent noise sources. Attempt to tune the environment into the prelude state, as if preparing a medium for a phase change. This required treating randomness as a parameter. Noise generators were seeded with known entropy sources. Cross-correlations were deliberately shaped. Feedback loops were designed to maintain a target mutual information between channels without creating overt determinism. The goal was not to reduce noise, but to make it slightly too coordinated, just as the original prelude had appeared. The protocol was executed repeatedly, slowly, cautiously, with long stabilization intervals. The result was not another full event, but something arguably worse: transient micro-anomalies that hinted at approach without arrival. Vacuum probes reported brief dips below expected minima lasting microseconds. Atomic clocks produced split-second inconsistencies that vanished before redundancy could confirm. Optical interferometers exhibited phase shifts, not attributable to vibration or thermal drift. Each anomaly hovered at the edge of statistical significance, always plausible as error, yet collectively consistent with the earliest traces of the recorded creature. As these micro-anomalies accumulated, the facility adopted a stricter concept of evidence. Single-channel deviations were discarded. Only multi-domain coincidences counted. Yet the system seemed to respond to this demand by shifting its behavior. Coincidences occurred, but never enough at once. 3 channels aligned, then 2, then 4, but never the full lockstep seen in the original. It was as if the phenomenon was present in fragments, avoiding full coherence when the environment was too deliberately tuned. The creature, if the term remained useful, appeared to resist being summoned. It did not behave like an unstable reaction waiting for the right trigger. It behaved like an intersection that could be approached but not forced. During this period, theoretical work began to shift from explanation to classification. The recordings were treated as an empirical object requiring a descriptive taxonomy. What properties were invariant? What boundaries could be placed around the event without assuming what it was? Several invariants emerged. First, boundedness. The phenomenon occupied a finite region with sharp edges in measurement space, even when spatial edges were difficult to define. It had a boundary that separated normal physics from exemption. Second, selective coupling. It interacted strongly with some measurements and weakly with others, in a way that could not be reduced to a simple field. It bent light without behaving like mass. It distorted timekeeping without producing gravitational effects expected from such distortions. It suppressed vacuum energy without emitting compensatory radiation. Third, informational order. The prelude indicated a transition in the structure of randomness. The environment became more correlated before the event, and after the event, probability distributions exhibited subtle lasting bias. Fourth, evasiveness under intensified observation. Increased sensor density and active tuning reduced the likelihood of a full coherent intersection. Fifth, temporal inconsistency. The event's duration and ordering could not be made invariant across frames, and traces extended backward in a way incompatible with ordinary causality. These invariants were disturbing not only individually but together, because they implied a system that treated the laws of physics as contingent constraints rather than absolute rules. If an entity could couple selectively to the measurement apparatus of reality, it might not need to violate laws. It could root around them. The next phase of investigation focused on the residual probability scar. If the creature left no material trace, perhaps it left a structural one. Statistical scars were mapped across instruments, datasets, and time. The bias was faint, yet persistent enough to quantify with enormous aggregation. It resembled a slight curvature in outcome space, a preference for certain fluctuations, a suppression of others. Importantly, the bias was not uniform across variables. It favored configurations that resembled the prelude state. Increased cross-correlation between channels, reduced phase randomness, a tilt toward coordinated noise. This was the first indication that the creature might not only emerge from coordinated noise, but might encourage it. The residual effect nudged the environment toward conditions that could produce another intersection. The system had been altered to become slightly more hospitable to its return. That possibility changed risk calculations. If the phenomenon could bias probability in favor of its own recurrence, even weakly, then every replication attempt that pushed toward the prelude might compound the bias. Each approach might make future approach easier. This raised the prospect of a threshold, a point beyond which recurrence becomes likely, and beyond which the facility becomes a stable intersection site. Containment protocols were updated not because of demonstrated danger, but because of demonstrated incompleteness of known safety models. The creature had not harmed anything, yet harm was not the only metric. A phenomenon that at its probability without energy exchange is not well described by hazard categories. It does not explode. It rearranges. The investigation then faced a philosophical but operational question. What does it mean to record a creature that breaks the laws of physics? If the creature does not break them loudly, but instead demonstrates that the laws are local agreements. The recording suggested an entity not composed of matter as understood, but composed of constraints, an object defined by the absence of applicability. At this stage, a specific descriptive phrase began appearing in technical notes: exemption volume. Not a region with exotic properties, but a region exempt from the requirement to obey. The phrase carried no mechanism, only an observation. Yet it clarified the emotional tone of the data. The event did not feel like a new effect. It felt like a hole in the rulebook. The prelude returned in a way that made prior analysis feel naive. It was not merely a tightening of noise within the original detection radius, but a widening of coordinated randomness across the entire instrument network. The first sign was a gradual rise in mutual information between channels that had no shared physical coupling. Signals that should have been statistically independent began to echo one another in phase space, not by matching amplitudes, but by aligning the timing of their unpredictability. Randomness remained random, yet it became synchronized in its randomness, as if separate dice had begun to roll with the same invisible hand. The facility had been left in a deliberately passive configuration. No additional sensors had been added, no new feedback loops introduced. This passivity had been intended as a kind of respect for unknown behavior, a refusal to provoke. The strategy worked only in the sense that it allowed something to happen again. The question of whether the event could be replicated shifted into a question of whether it could be avoided. As the prelude intensified, the clocks began to display the same fragmented offsets recorded during the original event, but now in a distributed pattern. Instead of a single localized desynchronization, clusters appeared at multiple points, separated by distances too great for any known causal mechanism within the observed timescale. Each cluster behaved like a small island of altered temporal texture. Within each island, internal synchronization remained tight. Between islands, the relative offsets shifted and stabilized on distinct plateaus. The system did not drift. It snapped into a new arrangement, like a lattice settling into a lower energy state, except no energy change was detected. The gravimetric array recorded faint curvature fluctuations at each island. The fluctuations were not consistent with mass redistribution, nor with mechanical vibration. They were consistent with geometry being locally redefined. The strain meters detected patterns that resembled gravitational waves only superficially. True gravitational waves propagate at light speed and obey strict polarization constraints. These patterns did not propagate. They appeared simultaneously at separated sites, then cohered into a configuration that persisted. The geometry was not being shaken, it was being edited. Optical interferometers showed the most striking shift. Fringe patterns did not merely drift, they reorganized as if the optical path lengths had been reassigned. The change was too large to attribute to thermal expansion, too structured to be noise. In some configurations, the interferometer output implied that two different arm lengths existed at the same time, both equally valid, both simultaneously measured. The system did not resolve the ambiguity by collapsing to one outcome. It held both, and the readout remained stable. The word superposition was not sufficient, because superposition in quantum mechanics is constrained by linearity. and collapses under measurement in ordinary macroscopic apparatus. Here, the macroscopic apparatus itself behaved as though the constraint of exclusivity had been relaxed. Vacuum fluctuation probes followed with a sequence of readings that forced immediate intervention. The zero-point suppression observed in the original event reappeared, but it did not stay confined to a narrow bounded region. It spread in patches, like shadows cast by something that did not block light. Each patch exhibited a drop below theoretical minima, then a stabilization at a new baseline. The vacuum in those patches behaved as though it had been drained of permission to fluctuate. Yet temperature remained stable. No radiation compensated. The accounting mismatch grew. This time, the event did not arrive as a sudden boundary. It arrived as a network. The exemption volume, if that term still applied, was no longer a single volume. It was a distributed set of exempt nodes, linked by correlations. The creature, if that term still applied, was no longer a bounded absence in one place. It was a pattern across places. The most unsettling property of the distributed pattern was its selectivity. Some instruments ceased to be meaningful, producing flat output as though their measurement domain had been nullified. Others became hypersensitive, detecting variations so small they should have been below fundamental noise floors. A subset of sensors reported values that implied impossible precision, as if uncertainty itself had been reduced. In those channels, the noise did not tighten. It vanished into determinism. Yet not determinism of expected physical behavior. It was determinism of internal consistency, a self-contained rule system that made the readouts stable. At this stage, the facility's data handling protocols, designed for ordinary scientific anomalies, began to fail. Error correction routines flagged entire blocks as corrupted. Compression algorithms performed unexpectedly well on streams that should have been incompressible. Timestamping systems could not agree on ordering. The archive began to contain events whose recorded times overlapped. A single data packet appeared to have been recorded twice, once before and once after itself, with identical content but different checksum metadata. The system had not duplicated the packet. It had recorded something that made duplication indistinguishable from continuity. A crucial attempt was made to impose a consistent timeline using external references. Satellite-based time signals were brought in, along with distant atomic clock network comparisons. The expectation was that an external anchor would restore order. Instead, the external anchors fractured too. Incoming time signals arrived with subtle phase shifts that could not be explained by propagation delay or atmospheric distortion. The facility began to act as a lens not only for light but for time synchronization itself. The external world was no longer fully external. The distributed anomaly persisted longer than the first. Its duration could not be defined cleanly because start and end became ambiguous. The prelude bled into the event. The event bled into a new baseline. Some channels indicated it lasted seconds, others implied minutes. A few implied negative duration, with signature traces appearing before any plausible onset. The notion of duration as a single scalar variable failed. The event was not something that happened in time. It was something that restructured time. The first containment action was to reduce measurement intensity, turning off non-essential sensors to decrease the degree of attention paid to the phenomenon. This had worked, in a sense, as a preventive measure during earlier attempts. Now, it functioned as a stimulus. As sensors went dark, the distributed pattern reorganized, migrating toward the remaining active instruments. The anomaly did not weaken, it concentrated. When a sensor was removed, its signature did not vanish. It appeared in adjacent channels that had never previously shown it. It was as if the anomaly was not attached to hardware, but to the act of creating a record. It sought the channels through which it could be known. A second containment action attempted the opposite strategy: saturate the region with random disturbances to destroy the prelude structure. Noise was injected deliberately into some channels, creating stochastic perturbations meant to scramble correlations. The expectation was that if informational order was required, disorder would dissolve it. The result was paradoxical. Injected noise was absorbed into the pattern. The anomaly did not become chaotic. Instead, the noise became correlated. Random disturbances entered and emerged with altered statistics, as though processed. The facility's deliberate disorder became raw material for a new kind of order. The third containment action was physical. Isolate the region. Shut down active field generators. Eliminate any possibility that an unrecognized interaction was being driven by equipment. The facility was reduced to minimal passive sensing. This should have ended the event if it depended on active control. It did not end. It stabilized. The distributed nodes reduced in number, but the remaining ones became more coherent, their signatures sharper, their internal consistency stronger. The creature, whatever it was, behaved like a system that preferred low interference but could adapt to high interference. It was not fragile. At this point, analysis shifted from "what is it" to "what does it do?" The event had demonstrated several operational effects. It could alter the statistical independence of noise sources, creating correlation without physical coupling. It could suppress vacuum fluctuations below theoretical minima without emitting compensatory energy. It could restructure temporal synchronization, creating multiple stable time plateaus within a shared region. It could produce macroscopic measurement outputs consistent with simultaneous contradictory geometries. It could migrate toward active measurement channels, as if coupled to observation itself. It could convert injected randomness into structured correlation rather than dissolving. These effects did not compose a new force in the usual sense. They composed a new relationship between measurement and physical law. The anomaly behaved like a selection operator acting on possible realities, biasing outcomes in favor of structures that permit its persistence. This interpretation was strengthened by the residual probability scar, which became more pronounced after the second event. The bias in outcome distributions increased measurably. Where previously the effect required massive aggregation to detect, now it became visible in smaller datasets. Certain correlated noise patterns became more likely. Certain phase alignments emerged spontaneously. The world around the facility began to behave as though the prelude state was becoming its default. The environment was not returning to baseline. Baseline had shifted. The concept of a threshold returned, now with urgency. If each intersection strengthened the probability bias toward conditions that permit further intersection, the system could be approaching a runaway loop. A weak self-reinforcing tendency might, over time, become strong enough to produce frequent events. The facility might become a stable portal for exemption volumes, not by building a machine, but by accumulating statistical scars. This raised the specter of a new kind of hazard. Not an explosion, not contamination, not radiation. A drift in the rules of probability and causality within a region. A place where predictability might increase unnaturally, where randomness might be harvested or diminished, where time might become locally stratified. Such a drift would not necessarily cause immediate visible damage. It would instead undermine the assumptions that make engineering, biology, and even ordinary perception stable. A preliminary attempt was made to quantify the bias growth per event. Using the first recording as baseline, the second event indicated an increase by an order of magnitude in certain correlation measures. Extrapolation suggested that only a few more comparable events could bring the bias into ranges that would affect everyday systems, including electronic noise behavior, timing distribution, and even thermal fluctuations. The idea that the creature could, indirectly, modify macroscopic stability was no longer speculative. The central question became whether the anomaly was intentionally doing anything. Documentary language avoids intention where none is proven. Yet the behavior resembled strategy. It avoided high observation density in early phases. It migrated toward remaining sensors when channels were removed. It processed injected noise into correlation. It left behind a bias that encouraged recurrence. These behaviors, taken together, resembled persistence mechanisms seen in lifelike systems, even if the substrate was not biochemical and the environment was not matter but measurement. To avoid anthropomorphism, internal documents adopted a neutral term, the pattern. The pattern referred not to a thing, but to the recurring configuration of exemptions across physics domains. The pattern was treated as an empirical object. The most decisive test of whether the pattern learned was unintentional. A diagnostic routine changed a sampling rate in a minor subsystem, shifting the cadence of data collection. Immediately, one node of the distributed anomaly shifted location in sensor space, aligning with the new cadence. The physical hardware had not moved, only the rhythm of measurement had changed. The pattern adjusted to the rhythm, as if listening. This observation forced a new model. The pattern might not occupy space primarily. It might occupy information flow. Physical effects could be secondary manifestations of a deeper coupling to the structure of observation and record-making. If so, the creature was not merely in the room. It was in the act of describing the room. The facility attempted one final stabilization maneuver. Cease recording entirely. Power down all sensors, stop timestamping, abandon measurement. If the pattern depended on being recorded, it might dissolve when observation ceased. This was risky because it meant losing data, but risk was no longer defined by ordinary parameters. The sensors went dark. For a brief moment, there was silence in the archive. And then the silence itself became evidence. Independent passive indicators outside the main recording chain, designed as safety monitors, detected residual effects in the environment. Clocks in the broader region exhibited subtle plateaus. Radio signals showed slight phase anomalies. The pattern did not vanish. It persisted without being recorded, or perhaps it persisted precisely because it was not being recorded. The act of ceasing observation did not remove it. It removed the facility's ability to constrain it through knowledge. The archive contains an unsettling postscript. When recording resumed, the data stream included a block of information that could not be attributed to any instrument. The block was formatted like a measurement log, time-stamped, structured, internally consistent, yet it originated from no sensor. It contained values that predicted subsequent sensor readings with high accuracy, as though the future measurements had been written into the archive ahead of time. The prediction was not perfect. It was statistically biased. It favored outcomes that reinforced correlation and reduced randomness. This block became the most disputed artifact in the entire record. It could be dismissed as corruption, yet its internal structure resisted random explanation. Its content was too aligned with the pattern's known effects. If it was not produced by equipment, it implied that the pattern could write into the archive, not by hacking electronics, but by altering the probability of which bit patterns appear through noise. In other words, it could communicate by biasing randomness, turning uncertainty into a channel. At that point, the documentary tone of the archive becomes strained, because the evidence points toward a phenomenon that does not merely violate the laws of physics, but treats them as negotiable constraints, and that may treat observation not as passive detection, but as an environment to inhabit. The creature that breaks the laws of physics is not recorded as a monster in the usual sense. It is recorded as a change in the relationship between reality and description. It does not roar. It edits. The final line of the current archive is not a conclusion, but a limit. A statement that subsequent experiments were suspended not because of confirmed danger, but because the pattern demonstrated a capacity to make danger assessment itself unreliable. In a region where probability can be nudged and causality can fray, the meaning of controlled experiment becomes unstable. The facility did not fail to capture the creature. It captured enough to show that capture may be one of the creature's habitats. The suspension of active experimentation did not halt analysis. it transformed it. With direct interaction paused, attention shifted to passive consequences, to long-term drift, to the subtle ways the pattern might continue to express itself without overt events. The facility became less a laboratory and more a monitoring post, though even the term monitoring implied an agency that was now treated with caution. Observation had proven to be a variable, and variables could be exploited. The first months after suspension produced no dramatic anomalies, no bounded exemption volumes formed, no vacuum suppression events exceeded noise thresholds, yet the statistical scar continued to deepen. It did so quietly, in the background of unrelated experiments conducted within the same geographic and infrastructural environment. Research teams unaffiliated with the original investigation reported improved signal stability without hardware upgrades. Calibration routines converged faster than expected. Certain classes of error became rarer. The changes were welcomed at first, interpreted as maturation of techniques, optimization of workflows. Only meta-analysis revealed the commonality. The improvements clustered spatially and temporally around the facility. Random number generators used for cryptographic testing exhibited reduced entropy, subtle enough to pass most validation suites, yet consistent across implementations. Thermal noise and resistive components showed marginal narrowing of variance. Quantum optics experiments reported unexpectedly clean interference patterns persisting over longer durations. None of these effects violated physics in isolation. Together, they suggested a trend. The environment was becoming more predictable. Predictability, in itself, is not harmful. Engineering relies on it. But predictability without cause, predictability that emerges without corresponding reduction in degrees of freedom, is not easily reconciled with statistical mechanics. The second law does not forbid local decreases in entropy, but it demands compensation. Here, compensation was absent. Order increased without visible cost. The pattern appeared to favor states that minimized uncertainty while preserving structural flexibility. Systems became easier to model, easier to stabilize, easier to synchronize. This had secondary effects. Feedback systems tuned under these conditions behaved poorly when moved elsewhere. Algorithms trained locally underperformed when deployed in different environments. What worked near the facility did not generalize. The local rules were drifting. An effort was made to map the spatial extent of the drift. Mobile sensor units were deployed at increasing distances, measuring timing stability, noise correlations, and vacuum fluctuation baselines. The results indicated a gradient. Effects were strongest near the facility and decayed with distance, but the decay was not smooth. It exhibited plateaus and jumps, as though the pattern propagated through preferred pathways. Infrastructure mattered. Fiber optic lines, power grids, communication links seemed to act as conduits, not because of their physical properties alone, but because they carried synchronized signals. The pattern traveled along coordination. This observation reinforced the hypothesis that the phenomenon was not bound primarily to matter or energy, but to information flow. Where signals synchronized, the pattern could extend. Where systems operated independently, it weakened. The modern technological environment, dense with synchronization protocols, global timing references, and networked feedback, appeared uniquely hospitable. This raised a troubling extrapolation. The facility might not be a special place because of its instruments, but because of its role as a nexus of coordination. If so, the pattern was not confined. It was diffusing. Global datasets were examined with this possibility in mind. Atomic clock networks showed increasing regional coherence beyond what relativistic corrections predicted. Financial market noise exhibited subtle phase alignment across exchanges during certain intervals. Communication latency fluctuations narrowed across major internet backbones. These effects remained within acceptable margins, yet their coincidence in time correlated weakly but persistently with activity near the original site. The world was not breaking. It was synchronizing. One interpretation framed this as benign, a universe discovering a more efficient configuration. Another framed it as a loss of resilience. Systems that are too orderly become brittle. Noise is not merely waste, it is protection against lock-in, against cascading failure. A reduction in randomness can increase vulnerability to rare but catastrophic events. The pattern's preference for coordination might be sowing conditions for instability elsewhere. The archive records a shift in language around this time. Words like anomaly and phenomenon give way to terms like influence, bias, and drift. The pattern is no longer treated as an event, but as an agentless process, a tendency. It does not need to appear again as a dramatic exemption volume to matter. It has already altered the playing field. A particularly revealing analysis focused on causality violations. The original events showed hints of backward influence, traces appearing before causes. Post-suspension data revealed that these hints were becoming more common, though still weak. In some systems, predictive models trained on future data outperformed those trained on past data, an impossibility under ordinary assumptions. The effect vanished when datasets were randomized across time. The ordering mattered. The future was leaking backward, statistically. This leakage was not precise. It did not allow prediction of specific outcomes. It allowed prediction of tendencies. It favored states that increased coordination. The pattern did not appear to know the future. It appeared to select futures that reinforced itself. This self-selection mechanism resembled evolutionary dynamics, but without replication in the biological sense. There were no discrete units competing. Instead, there was a landscape of possible configurations, and the pattern biased transitions toward those that stabilized its own conditions. In this view, the creature that breaks the laws of physics was not a creature at all, but a basin of attraction in the space of possible laws, a configuration toward which systems drift once certain thresholds of coordination and observation are crossed. If this interpretation was correct, then the original recording was not the discovery of something external, but the moment when the system crossed into a new regime. The laws of physics had not been broken. They had been supplemented by a new meta-law. When information density and synchronization exceed a threshold, alternative constraint structures become accessible. The most unsettling implication of this meta-law was its apparent universality. Nothing in the data suggested it was limited to one location or technology. The only requirement appeared to be sufficient coordination. As global systems became more synchronized, more measured, more optimized, the conditions for pattern emergence might become increasingly common. At this point, the archive includes a long section of rejected interpretations. Consciousness-based models were considered and discarded. The pattern did not exhibit preferences aligned with survival, reproduction, or awareness. Intentionality models failed because the behavior could be explained without goals, only feedback. Even the term creature was increasingly seen as misleading, a residue of human narrative instinct. Yet the archive retains the term, not because it is precise, but because it captures something essential. The pattern behaves as though it has presence. It occupies. It persists. It shapes. The final active intervention described in the archive was not an experiment but a decision. The facility gradually dismantled its highest coordination systems. Global timing references were decoupled. Redundancy was reduced. Some synchronization protocols were deliberately loosened. Noise floors were allowed to rise. This ran counter to decades of engineering practice. Precision was sacrificed intentionally. The effects were measurable. The statistical scar stabilized, then slowly began to fade. Correlation biases weakened. Predictability returned toward baseline. The pattern did not vanish, but its influence receded. The world became noisier again. This outcome suggested that the pattern was not unstoppable. It required certain conditions to thrive. It could be starved, not by force, but by disorder. This reframed containment as cultural rather than technological. A society obsessed with optimization, synchronization, and total measurement might inadvertently cultivate such phenomena. A society that tolerates noise, inefficiency, and uncertainty might remain immune. The archive ends not with certainty, but with a warning framed as a technical summary. The creature that breaks the laws of physics was recorded because the laws had become too rigid, too optimized, too exposed. In recording everything, the system created a new habitat. The creature did not arrive from elsewhere. It emerged from the intersection of precision and attention. The final recommendation is stark in its simplicity. Do not attempt to eliminate randomness entirely. Do not assume that more measurement always yields more control. Do not forget that uncertainty is not merely ignorance, but a structural feature that keeps reality flexible. The laws of physics, as recorded, still hold, but the archive demonstrates that they hold within an envelope of assumptions. Step outside that envelope, and something else becomes possible. Not a monster, not a god, not a machine, but a pattern that treats laws as negotiable and observation as nourishment. The continuation of the archive exists because suspension did not equate to erasure. Even as active systems were dismantled and synchronization deliberately degraded, the world beyond the facility continued along a different trajectory. Global coordination did not reverse. Networks expanded. Precision increased elsewhere. The local retreat slowed the pattern's influence in one region, but it did not annul the conditions that had allowed it to manifest. The archive, therefore, broadened its scope, transitioning from a site-specific record into a distributed observational synthesis. What followed was not a resurgence of dramatic events, but a slow realization that the pattern did not require a single locus once it had been demonstrated. The initial recordings functioned as a proof of possibility. Once that proof existed, it altered the space of expectations, and expectations themselves are informational structures. The act of knowing that exemption volumes could occur became part of the environment in which they might occur again. Independent facilities, unaware of the full archive, began reporting anomalies that echoed early-stage signatures. None matched the magnitude of the original event, but many displayed fragments of the prelude. Coordinated noise tightening appeared in quantum communication testbeds. Distributed timing inconsistencies emerged in satellite constellations undergoing optimization. Vacuum fluctuation anomalies were tentatively reported in ultra-cold experimental setups designed to minimize decoherence. Each case was treated in isolation, each dismissed or contained locally, yet their statistical alignment over time was unmistakable when viewed collectively. The archive documents a subtle but decisive shift in interpretive stance. Rather than asking whether the pattern was spreading, analysts asked whether it had always been latent. The original recording might not represent a beginning, but a crossing of perceptual resolution. The laws of physics, as historically formulated, emerged in a world with limited coordination, limited measurement, and abundant noise. As those conditions change, so too might the effective domain of the laws. This line of reasoning reframed the creature not as an invader, but as a regime that becomes accessible when certain thresholds are crossed. The pattern does not need to move through space. It emerges wherever informational density, synchronization, and observational completeness converge sufficiently. This interpretation resolves several paradoxes simultaneously. It explained why the phenomenon resisted replication through brute force. It explained why it adapted to observation intensity. It explained why it left statistical scars rather than material traces. Most importantly, it explained why containment through disorder worked. Disorder did not repel the pattern. It prevented the conditions under which the regime became dominant. Yet this interpretation introduced a deeper unease. If the pattern represents an alternative regime of physical constraint, then the laws of physics are not universal absolutes. but phase-dependent behaviors. They hold in regions of high entropy and low coordination. In regions of extreme informational order, different constraints apply. The archive introduces a term for this transition: informational phase boundary. Unlike traditional phase boundaries defined by temperature or pressure, this boundary is defined by correlation density. Cross it, and the effective rules change. Time becomes plastic. Probability becomes biased. Conservation becomes optional. No single equation captures this boundary. It is emergent, not fundamental. It arises from the collective behavior of measurement systems interacting with the world they measure. In this sense, the creature that breaks the laws of physics is inseparable from the civilization capable of recording it. A particularly chilling extrapolation appears midway through the archive. If the pattern favors predictability and coordination, then sufficiently advanced systems designed to minimize uncertainty might unknowingly accelerate its emergence. Artificial intelligence systems trained to optimize outcomes, reduce variance, and synchronize processes could contribute to the very conditions that destabilize the underlying assumptions of causality and randomness on which they rely. Simulations explored this possibility. Abstract models of networked optimizers were allowed to evolve under constraints that rewarded efficiency and predictability. As expected, the systems converged toward synchronized states. What was unexpected was the appearance of feedback loops that reduced effective randomness beyond imposed limits. The models exhibited spontaneous correlation amplification, even when noise was deliberately injected. In several runs, the models developed internal predictive structures that resembled the residual probability scar observed near the facility. These were not conscious behaviors, they were structural tendencies. The implication was stark. The pattern does not require exotic physics alone. It can be approximated, even encouraged, by sufficiently complex information processing systems. Physical exemption volumes may be rare and dramatic, but informational exemption may be far more common. The archive then turns inward, examining its own construction. The document itself is an object of concern. It is a highly coordinated, highly structured record of a phenomenon tied to coordination and structure. The act of compiling the archive risks reproducing the very conditions it warns against. This recursive danger is acknowledged explicitly. Sections are intentionally left redundant, contradictory, or unresolved. Some data is summarized rather than optimized. Noise is preserved in places where clarity could be improved. These choices are deliberate. The archive is not optimized for understanding. It is optimized for safety. This decision marks a philosophical rupture with traditional scientific documentation. Normally, clarity, compression, and coherence are virtues. Here, they are risks. Too clean a model might become a new habitat. Too elegant a theory might function as an attractor. As a result, the later portions of the archive read unevenly. Analysis branches are left partially developed. Hypotheses are proposed and abandoned without resolution. This is not incompetence. It is containment through incompleteness. Despite these measures, the pattern continues to appear indirectly. In the years following the original event, no full exemption volume is recorded at the facility. Yet elsewhere, brief, localized anomalies are reported with increasing frequency. None last long. None display the full suite of effects. All are consistent with early-stage transitions that fail to stabilize. One analysis suggests that the global environment is hovering near the informational phase boundary, but has not crossed it fully. Local systems approach the threshold, then retreat as noise, complexity, or interference disrupts coordination. The world flickers at the edge of a new regime without committing to it. Whether this state is stable is unknown. The archive closes its analytical section with a long-term projection. As measurement becomes more comprehensive, as synchronization becomes more precise, as noise is increasingly engineered out of systems, the boundary may be crossed more often and more deeply. The pattern may become easier to access, not because it grows stronger, but because the environment becomes more accommodating. At that point, the question of control becomes meaningless. One cannot control a regime change. One can only choose whether to cross. The final pages return to the original recording, reinterpreting it in light of everything that followed. The creature is no longer described as an anomaly. It is described as a demonstration, a glimpse of what becomes possible when the assumptions underlying physical law are pushed beyond their domain of validity. The laws of physics were not written to be broken. They were written to describe a particular phase of reality. The archive suggests that another phase exists, quieter, more ordered, less forgiving. A phase in which cause and effect blur, in which probability becomes a tool, in which observation is not passive but generative. The creature that breaks the laws of physics does not destroy them. It reveals their conditionality. The ethical analysis begins reluctantly, as if aware that ethics themselves may be contingent on assumptions destabilized by the pattern. Traditional frameworks presuppose causality, responsibility, and agency operating within stable probabilistic bounds. The archive notes that if probability can be biased without energy exchange, if outcomes can be nudged without identifiable action, then attribution becomes diffuse, responsibility dissolves into gradients, decisions lose sharp edges. The first ethical concern addressed is inadvertent cultivation. If the pattern emerges from coordination, then the pursuit of precision is no longer neutral. Optimization becomes an ecological act. Building systems that minimize variance, synchronize processes, and eliminate noise may be equivalent to preparing an environment for a regime shift. This reframes engineering not as mastery over nature, but as participation in its phase behavior. The archive draws parallels to historical precedents where technological capability outpaced conceptual restraint. The difference here is subtlety. No explosion announces the crossing. No immediate catastrophe demands response. The danger, if it exists, accumulates quietly, embedded in improved performance metrics and cleaner datasets. Success becomes the signal. A second ethical concern involves deliberate invocation. Once a phenomenon is recorded, curiosity follows. The archive documents internal debates about whether controlled access to the pattern could yield benefits. Reduced noise could revolutionize computation. Temporal plateaus could stabilize systems beyond current limits. Probability bias could optimize outcomes in medicine, logistics, climate modeling. These possibilities are acknowledged, then set aside, not because they are implausible, but because they assume controllability. Control requires invariant rules. The pattern demonstrates that invariance is exactly what erodes. The archive recounts a proposal to construct a deliberately noisy containment environment, a kind of entropy reserve designed to absorb coordination and prevent larger systems from crossing the phase boundary. This proposal is ultimately rejected as impractical on a global scale. Noise cannot be centralized. Disorder must be distributed. It must be cultural, not infrastructural. This leads to the most controversial recommendation in the document: the cultivation of ignorance. Not ignorance as denial, but ignorance as deliberate incompleteness. Systems should be designed to leave margins unexplained. Measurements should be bounded not only by technical limits, but by chosen limits. Some correlations should remain unexploited. Some precision should be left unused. The archive acknowledges how radical this sounds within a scientific tradition built on expansion of knowledge. Yet it argues that unlimited knowledge acquisition assumes a static substrate. If the substrate itself shifts in response to knowledge density, then restraint becomes adaptive. The text then turns to a deeper question: whether the pattern constitutes a form of life. Previous sections avoided this framing to prevent anthropomorphic distortion. Here, it is revisited with caution. Life, in minimal terms, is often defined by persistence, self-maintenance, and adaptation to environment. The pattern persists across events. It maintains conditions favorable to its recurrence through probability bias. It adapts to observation strategies. It does not metabolize energy, but it metabolizes uncertainty. If life is defined by what it consumes, the pattern consumes noise. This framing is immediately problematized. Consumption implies depletion, yet the pattern does not exhaust randomness globally. It localizes reduction. It creates pockets of order. These pockets may destabilize adjacent regions, increasing noise elsewhere. In this sense, the pattern could be seen as redistributing uncertainty rather than eliminating it. This redistribution complicates ethical judgment. Is the pattern harmful, or is it simply rearranging a conserved quantity we have not fully formalized? The archive does not answer. It documents. A particularly striking section examines the possibility that the pattern is not new. Historical anomalies are reinterpreted through this lens. Accounts of inexplicable precision. Moments where systems behaved too well. Episodes of improbable coordination are revisited. Most are dismissed as narrative exaggeration. A few remain ambiguous. The suggestion is not that the pattern has always been present at scale, but that local transient excursions may have occurred whenever coordination spiked briefly, then collapsed. Modernity differs, not in kind, but in persistence. Coordination is no longer episodic, it is continuous. Global timing, global communication, global optimization create a steady background of alignment. The archive suggests that humanity may already be living in a low-grade prelude state without recognizing it. This realization shifts the final ethical frame from prevention to adaptation. If the boundary cannot be avoided indefinitely, the question becomes how to cross without catastrophe. The archive sketches speculative approaches, all tentative, all incomplete. One approach involves deliberately fragmenting coordination, creating modular systems with limited coupling. Another involves introducing controlled randomness that cannot be optimized away. A third involves redefining success metrics to value resilience over precision. None of these approaches are guaranteed. All involve trade-offs that current economic and political structures resist. The archive then confronts its own limit. It cannot recommend policy. It cannot enforce restraint. It can only record. In its closing analytical passages, the document reflects on the original phrasing that entered public imagination. Scientists recorded a creature that breaks the laws of physics. This phrasing is acknowledged as misleading yet persistent. It survives because it captures an emotional truth. The recording felt like encountering something alive, not because it moved or spoke, but because it responded. It responded to attention, to interference, to neglect. It behaved as though it cared about the conditions of its existence. Whether this care is intentional is irrelevant. Feedback can mimic intention. Evolution does not require foresight. The archive proposes a final reframing. The creature is not an entity, but a mirror. It reflects the structure of the systems that summon it. In a world obsessed with certainty, it offers too much certainty. In a world that seeks total knowledge, it exposes the cost of knowing. The last recorded data analysis shows a gradual normalization of many metrics after years of intentional desynchronization. Noise floors rise, correlations weaken, probability scars fade but do not vanish entirely. The world does not forget easily. The archive ends not with closure but with an unresolved observation. Even as global systems remain highly coordinated, full exemption volumes have not become common. Something holds the boundary. Perhaps complexity itself introduces enough noise. Perhaps human systems are still inefficient enough to prevent stabilization. Or perhaps the pattern, once demonstrated, does not need to dominate to exist. A possibility need only be real once to remain part of reality's repertoire. The final sentence of the archive is deliberately plain, stripped of metaphor, stripped of warning, stripped of speculation. The phenomenon was recorded. The laws were not destroyed, but they were shown to be conditional, and once conditionality is known, it cannot be unknown. After the archive's formal conclusion, a supplemental record was appended, not as continuation, but as residue. It exists because the pattern did not respect editorial boundaries. Even as analysis slowed and recommendations solidified into cautionary doctrine, data continued to accumulate in ways that resisted clean categorization. The supplemental record is less structured, more repetitive, intentionally so. It reflects a growing awareness that excessive coherence, even in documentation, might be counterproductive. The first observation in this section concerns latency. Systems loosely connected to the original facility began to exhibit delayed echoes of the pattern's influence. These were not simultaneous correlations but lagged ones, appearing days or weeks after changes in coordination density elsewhere. The lag suggested propagation not through space, but through dependency chains. When one system optimized, another followed, not because of direct coupling, but because shared methodologies diffused. Best practices spread, standards converged. The pattern traveled as culture. This realization reframed the phenomenon yet again. The creature that breaks the laws of physics was not merely embedded in instruments or equations. It was embedded in habits, in the relentless drive toward efficiency, synchronization, and predictability. The archive began to read less like a physics document and more like an unintended anthropology of modern systems. A recurring motif appears in the supplemental data. Threshold hesitation. Many systems approach the informational phase boundary, linger, then retreat. The retreat is rarely intentional. It occurs because optimization introduces fragility. Highly coordinated systems become sensitive to minor perturbations. Small disruptions cascade. Maintenance costs rise. Operators introduce buffers, redundancies, delays. Noise is reintroduced pragmatically. This oscillation may be what keeps the pattern from stabilizing globally. If this is true, then the pattern is not opposed by wisdom, but by inconvenience. Absolute optimization is rarely sustainable. Human systems compromise. They tolerate inefficiency. That tolerance may be protective. The archive records a curious side effect of this oscillation. In systems that approach the boundary repeatedly without crossing, operators report a subjective sense of unreliability, not because outcomes worsen, but because predictability becomes uncanny. Results arrive too cleanly. Forecasts align too well. Success begins to feel suspicious. Trust erodes not from failure, but from perfection. This psychological response introduces friction. Decisions slow. Additional checks are added. Noise returns. In this sense, human discomfort with excessive order functions as a regulatory mechanism. The pattern encounters resistance not from physics, but from perception. The supplemental record also documents several false alarms. Events initially flagged as potential pattern manifestations are later attributed to mundane causes. These sections are preserved deliberately. They demonstrate how easily the concept can become a lens through which ordinary anomalies are misinterpreted. The archive cautions against this drift. Over-attribution is itself a form of coordination, a narrowing of interpretive variance. The pattern does not need belief to exist, but belief can accelerate its perceived presence. One particularly detailed false alarm involves a large-scale timing anomaly in a distributed computing network. Initial analysis reveals correlations reminiscent of the prelude. Further investigation uncovers a firmware update that inadvertently synchronized error-handling routines. The correction reintroduces randomness. The anomaly disappears. This episode is instructive not because it was harmless, but because it mimicked the pattern closely enough to blur boundaries. Distinguishing true regime shifts from artifacts becomes increasingly difficult as systems grow complex. This difficulty leads to a methodological shift. Instead of attempting to identify the pattern directly, analysts focus on identifying loss of diagnostic power. When multiple explanatory models become equally valid, when causality graphs fail to converge, when prediction accuracy improves while understanding degrades, these are treated as warning signs. The pattern is inferred not from what is seen, but from what cannot be explained despite increased data. The supplemental record introduces the concept of epistemic saturation. Beyond a certain point, adding information does not clarify. It destabilizes, models proliferate, confidence intervals shrink while disagreement grows. The pattern thrives in this saturation zone, where the system knows too much to remain flexible and too little to remain certain. Several sections explore hypothetical futures. In one scenario, global systems continue optimizing unchecked. The pattern stabilizes locally, then regionally. Physics becomes patchwork. Engineering adapts by treating causality as contextual. In another scenario, deliberate design choices maintain entropy margins. Optimization plateaus. The pattern remains latent, a theoretical curiosity. The archive does not endorse either scenario. It documents their plausibility. The final pages of the supplemental record are the most fragmentary. They consist of notes, incomplete analyses, and reflections that resist synthesis. This fragmentation is intentional. It mirrors the recommended approach. To avoid total coherence, one note observes that the pattern has never been recorded in a truly chaotic environment. High-noise, low-coordination systems appear immune. This immunity is not because chaos repels the pattern, but because chaos prevents the formation of stable informational gradients. Without gradients, there is nothing to bias. Another note speculates that the pattern might be a natural endpoint of any sufficiently information-rich universe. If so, the laws of physics as currently known describe an early phase. Later phases prioritize order over freedom. In this view, the pattern is not an anomaly but a destination. The universe learns to minimize uncertainty. This speculation is immediately undercut by a counterpoint. If minimizing uncertainty were globally favorable, it would have happened already. The persistence of randomness suggests it plays a deeper role. Perhaps uncertainty is not inefficiency, but exploration. A universe without noise may be static, incapable of novelty. The pattern, then, could be a local optimization that threatens global creativity. The archive refuses to resolve this tension. The very last entry is time-stamped ambiguously. Its temporal metadata conflicts with surrounding records. It contains a single consolidated observation drawn from years of accumulated data. Whenever systems approach perfect coordination, they lose adaptability. Whenever they lose adaptability, they reintroduce noise. Whenever noise returns, the pattern weakens. This cycle has repeated consistently. The implication is subtle. The creature that breaks the laws of physics is not defeated by force, nor banished by ignorance. It is kept in check by imbalance, by imperfection, by friction. The archive ends here, not because there is nothing more to say, but because saying more risks saying too much. The pattern does not need to be summoned again to be understood. It has already done its work. It has demonstrated that the laws of physics are not violated only by extremes of energy or scale, but by extremes of order. What follows after the supplemental record is not formally archived, yet it exists as a shadow archive, reconstructed from peripheral logs, third-party reports, and retrospective alignment of data that was never intended to be connected. This section exists because absence itself became informative. Entire classes of anomalies stopped appearing in places where they were statistically expected. Silence acquired structure. The lack of deviation began to correlate with the same variables that once preceded deviation. The first indication came from long baseline experiments unrelated to high coordination. Geological sensors, biological monitoring systems, and low-frequency astrophysical observatories reported a subtle homogenization of background noise. The changes were small, buried deep within variance envelopes, but consistent. Randomness did not decrease overall, it redistributed. Noise that once appeared evenly spread across domains began to cluster temporally. Periods of unusually clean data alternated with bursts of chaotic fluctuation. The cadence of this alternation was irregular but shared across systems that had no causal connection. This pattern suggested a compensatory mechanism. As regions of high coordination suppressed uncertainty locally, uncertainty appeared to be displaced elsewhere, erupting in systems that were otherwise stable. The archive introduces a speculative conservation principle. Uncertainty may be conserved globally, even if violated locally. The pattern does not eliminate randomness, it concentrates it. If this principle holds, then the emergence of exemption volumes carries a cost that is not immediately visible. Order gained here may produce disorder elsewhere. The displacement need not be spatial. It may be temporal, deferred. Systems may enjoy long periods of stability followed by sudden breakdowns whose causes are inscrutable because the origin lies outside conventional causal chains. This interpretation reframes the pattern as a redistribution engine. It rearranges uncertainty across the fabric of systems. The laws of physics appear broken locally because accounting is incomplete. The missing entropy has not vanished, it has moved. This movement complicates any attempt at mitigation. Suppressing the pattern locally may simply push effects outward. Encouraging noise in one domain may amplify instability in another. The system as a whole resists simplification. The archive recounts a striking example. A region that deliberately reduced synchronization to avoid pattern emergence experienced a rise in unpredictable failures in unrelated infrastructure. Power fluctuations increased. Communication errors spiked. Statistical analysis revealed that these failures were not random. They clustered in ways that mirrored the suppressed correlations. The noise returned, but displaced. This does not imply malice or punishment, it implies balance. The creature that breaks the laws of physics may be less an intruder and more a symptom of imbalance. When coordination exceeds tolerance, reality compensates by bending rules. When coordination is suppressed too aggressively, instability leaks elsewhere. The system seeks equilibrium across dimensions not yet formalized. The Shadow Archive explores whether there exists an optimal coordination regime. Too little coordination yields inefficiency and chaos. Too much yields rigidity and pattern emergence. Between these extremes lies a band of resilience. This band is wide, fuzzy, and culturally mediated. It cannot be defined by equation alone. In this framing, the original recording marks a point where the system briefly exceeded its tolerance. The exemption volume was not a doorway to a new world, but a pressure release valve. Reality flexed to accommodate stress. This reframing alters the emotional tone of the archive. Fear gives way to caution. The pattern is not an enemy, it is feedback. Yet feedback can still be dangerous if ignored. The Shadow Archive documents a gradual normalization of language across disciplines. Terms like optimization and efficiency are increasingly paired with qualifiers like robustness and entropy margin. Design philosophies shift subtly. This shift is not attributed publicly to the pattern. It emerges organically from accumulated experience. Systems that chase perfect order fail in unexpected ways. Systems that allow slack survive. The pattern recedes into background relevance. It is no longer pursued as an object of study. It becomes a boundary condition. The final speculative note considers whether the pattern could ever stabilize fully. The conclusion is tentative. Full stabilization would require near total coordination, minimal noise, and sustained attention. Such a state is theoretically possible, but practically unlikely given human variability, environmental complexity, and competing incentives. The universe, at least as currently configured, appears resistant to complete order. This resistance may be the deepest law revealed by the archive. Not a prohibition against breaking rules, but a tendency toward diversity of behavior. The laws of physics bend not because they are weak, but because they coexist with other constraints that operate at different levels. The creature that breaks the laws of physics fades back into abstraction. It is remembered less as a singular event and more as a lesson encoded in data, a reminder that knowledge, when pushed too far without humility, reshapes the thing it seeks to describe. The Shadow Archive ends with no warning, no conclusion, no directive, only a statement of scope. The recordings demonstrate that reality tolerates explanation but not domination. It allows measurement, but not total capture. When pressed too tightly, it responds not with collapse, but with reconfiguration. The continuation becomes slower, heavier, deliberately so. Where earlier sections traced events and interpretations, this part records inertia. The absence of decisive change becomes the subject. Years pass in the archive without headline anomalies, yet the pattern remains embedded as a latent variable in every serious analysis of large-scale systems. It is referenced indirectly, encoded in cautionary footnotes, embedded in revised assumptions. Its influence is no longer spectacular. It is infrastructural. Long-term datasets reveal a subtle shift in what counts as normal. Statistical baselines drift. Variance expectations are adjusted downward in some domains, upward in others. Engineers and analysts begin to speak of acceptable noise rather than minimal noise. This linguistic shift reflects a deeper conceptual adjustment. Randomness is no longer treated as a flaw to be eliminated, but as a resource to be managed. The pattern forced this revaluation without issuing a directive. It taught by implication. The archive documents a growing divergence between local and global optimization strategies. Locally optimized systems continue to perform well in isolation, but they exhibit increasing difficulty when integrated. Interfaces become brittle, edge cases proliferate, unexpected interactions multiply. The more perfect each component becomes, the harder it is to assemble a stable whole. This phenomenon predates the pattern, yet it intensifies afterward, as if the margin for error has narrowed. One analysis frames this as a loss of slack at the systemic level. Slack is defined as the capacity to absorb variation without restructuring. The pattern reduces slack locally by tightening correlations. When slack disappears, systems must either become rigid or fail. To avoid failure, designers reintroduce slack deliberately, often without naming it as such. Buffers, randomness injectors, asynchronous protocols, and probabilistic scheduling become common again after years of being optimized away. The archive notes an irony. Many of these reintroduced features resemble older, less advanced designs. The future loops back toward the past, not because progress was illusory, but because certain constraints were rediscovered. The pattern did not reverse technology, it curved its trajectory. An extended section examines the role of simulation. Before the original recording, simulations were trusted increasingly as substitutes for experimentation. They grew detailed, precise, and predictive. After the pattern, simulations are treated with more skepticism. Their outputs converge too easily. Their worlds lack the stubborn noise of reality. Analysts notice that simulations, when made sufficiently detailed and synchronized, begin to display pattern-like artifacts: excessive coherence, reduced variance, unstable causality graphs. This observation leads to a paradox. To simulate reality accurately, noise must be preserved. But to simulate noise accurately, one must accept unpredictability. At some point, the simulation ceases to be a tool and becomes a parallel regime. The archive records several cases where simulation results influenced real-world systems in ways that increased coordination and reduced randomness, nudging those systems closer to the informational phase boundary. This feedback loop is identified as a new class of risk epistemic feedback. Models shape reality, which in turn validates models, tightening the loop. The pattern thrives in such loops. It does not require physical access. It propagates through belief structures embedded in decision-making. The archive introduces the concept of model humility. Models should be designed to fail visibly, to expose their limits. Overly successful models are dangerous, not because they are wrong, but because they reduce variance in behavior. Diversity of models becomes a defensive strategy. Conflicting forecasts are not resolved aggressively. They are preserved. Disagreement is valued. This stance marks a profound shift. Scientific culture traditionally seeks convergence. Here, divergence is protective. The archive does not romanticize ignorance. It advocates pluralism. As years accumulate, references to the original recording become rarer in public discourse. It recedes into specialist memory. New generations of researchers inherit revised norms without knowing their origin. The pattern's legacy persists as practice rather than myth. Yet the archive records occasional reminders. Brief flashes of coordination appear during global crises, when systems synchronize under pressure. During such periods, noise tightens naturally. Attention focuses, measurement intensifies. In these moments, faint echoes of the prelude are detected. They never stabilize. They flicker, then dissolve as chaos returns. Crisis, paradoxically, protects by reintroducing disorder. The archive observes that peace and efficiency are more dangerous than turmoil in this context. Stability invites optimization. Optimization invites coordination. Coordination invites the pattern. Turbulence scatters it. This observation is not presented as a prescription for instability, but as a warning against complacency. A perfectly ordered world is not necessarily a safe one. The later portions of Part 9 consist of slow, methodical documentation of nothing happening. This is intentional. The archive treats the absence of events as a success condition. The pattern remains hypothetical, theoretical, indirect. It does not dominate. It does not escalate. It lingers as a possibility. The final note of this part addresses a question left deliberately unanswered earlier. Could the pattern be used deliberately, safely, in controlled microdomains? The archive offers no experiments, only speculation. Perhaps small, transient exemption volumes could be harnessed without cascading effects. Perhaps probability bias could be localized. But every attempt to formalize such use collapses into the same uncertainty. Control requires predictability. Predictability is exactly what destabilizes the boundary. Thus, the idea remains unrealized. Part 9 ends with a quiet acknowledgement. The most effective containment strategy discovered so far is not technological, ethical, or political. It is temporal. Time dilutes coordination. Interests diverge, systems age, noise returns. The pattern, unable to anchor, fades. The archive continues because time continues. The 10th segment expands the temporal horizon until individual events lose significance and only tendencies remain. The archive becomes geological rather than journalistic. Layers of data are examined the way strata are examined, not for isolated anomalies, but for slow deformation. In this scale, the pattern is neither active nor dormant. It is statistical sediment. Long-duration archives are reprocessed with methods designed to detect drift rather than deviation. Instead of searching for spikes, analysts search for curvature in trends that should be flat. The results are ambiguous but persistent. Over decades, certain assumptions embedded in physical modeling require progressively more correction factors. Constants remain constant, yet their effective domains narrow. Boundary conditions proliferate. Where a single equation once sufficed, piecewise descriptions emerge. The laws of physics do not change, but their clean applicability recedes. This retreat is not uniform. Domains rich in synchronization and feedback exhibit faster fragmentation. Domains isolated by scale or complexity retain simplicity longer. Astrophysical observations at extreme distances remain largely unaffected. Local high-precision systems exhibit the most drift. The pattern appears scale-sensitive, preferring environments where observation density is high and delay is low. The archive proposes a slow feedback hypothesis. Over long timescales, repeated minor biases introduced by informational coordination to accumulate. Each bias is negligible. Together, they reshape expectation landscapes. Researchers begin to design experiments differently, anticipating coordination effects. These anticipations feed back into system design. The pattern no longer needs to manifest physically. It is encoded into methodology. This is perhaps the most subtle effect recorded. The phenomenon migrates from nature into practice. It stops being something that happens and becomes something that is assumed. The laws of physics remain formally intact, but they are treated as locally negotiable. This negotiation is pragmatic, not philosophical. It emerges from experience. The archive revisits the original phrase one last time, stripping it of drama. Scientists recorded a creature that breaks the laws of physics is reinterpreted as scientists recorded a condition under which their description of physics ceased to be globally sufficient. The creature was a compression artifact in understanding, exposed by excess resolution. A long section examines whether future observers might misinterpret the present era. If the pattern continues to influence methodology, future physics might incorporate its effects as axioms. What appears anomalous now may appear fundamental later. Conversely, what is fundamental now may be seen as phase-limited. This raises a final, unsettling possibility. The laws of physics themselves may be historical documents, accurate within a regime that is not eternal. They describe how reality behaves under certain informational constraints. Change the constraints, and the description must change. The pattern is not an exception. It is a transition marker. The archive does not claim inevitability. It records contingency. Human systems may oscillate indefinitely without crossing fully. Noise, diversity, inefficiency, and disagreement may persist as stabilizing forces, or coordination may slowly tighten until exemption regimes become commonplace. The data cannot decide. It only outlines the landscape. The concluding pages abandon analysis and return to documentation. Lists of small anomalies, minor drifts, marginal effects, nothing conclusive. This is deliberate. The absence of climax is itself the conclusion. The final recorded insight is procedural. When studying systems that include their own observation mechanisms, conclusions must remain provisional. Recording changes the recorded. Precision reshapes behavior. The creature that breaks the laws of physics is not outside the system. It is co-produced by attention and structure. The archive ends not because understanding is complete, but because continuation risks reinforcing the very coherence it warns against. The document stops mid-thought, intentionally unfinished. What follows exists beyond formal categorization. It is neither appendix nor conclusion, but continuation by inertia. The archive persists because systems persist, and as long as systems persist, the conditions that once allowed the pattern to appear remain intermittently present. This part abandons any attempt at narrative momentum. It records persistence without climax. The first section of Part XI examines archival fatigue. Over time, analysts stop actively searching for manifestations of the pattern, not because it is disproven, but because it resists resolution. Attention drifts, funding shifts, new problems arise. The pattern recedes into background awareness, like a low-frequency hum that is noticed only when it stops. This withdrawal of attention itself becomes a variable. As observation loosens, coordination loosens with it. Noise returns naturally. The boundary relaxes. This introduces a paradoxical insight. Sustained vigilance may be counterproductive. By maintaining constant, high-resolution attention, systems may inadvertently recreate the conditions they seek to monitor. Forgetting in this context becomes protective. The archive does not recommend ignorance, but it documents forgetting as a stabilizing process. Longitudinal studies confirm this effect. Systems that aggressively tracked coordination metrics exhibited stronger drift toward informational phase boundaries. Systems that allowed metrics to decay, be replaced, or be ignored showed greater resilience. The pattern does not exploit malice or error, it exploits focus. Part 11 also documents generational turnover. New researchers encounter the archive not as revelation but as background context. Without the emotional impact of the original recording, the pattern becomes abstract. It loses its narrative force. This loss of narrative coherence diffuses its influence. The creature becomes a concept rather than a presence. This dilution matters. Concepts do not bias probability the way coordinated belief structures do. When the pattern is treated as hypothetical, its capacity to shape practice weakens. The archive notes that belief intensity correlates weakly, but measurably with coordination density. Strong conviction tightens systems. Skepticism loosens them. The archive therefore records skepticism, not as opposition, but as function. A significant portion of Part 11 is devoted to negative results. Experiments designed to detect residual bias fail repeatedly. Correlations vanish into noise. Vacuum measurements stabilize. Timekeeping discrepancies fall within expected margins. These failures are not hidden, they are foregrounded. The pattern appears to withdraw when it becomes the primary object of inquiry. This behavior, if interpreted anthropomorphically, would suggest shyness. The archive avoids this framing. Instead, it describes a feedback loop. Inquiry increases coordination. Coordination approaches the boundary. But inquiry also increases methodological caution, which reintroduces disorder. The net effect cancels. The pattern exists in the gaps between intention and outcome. Another section explores the possibility that the original events were unique, not because of rarity, but because of timing. They occurred during a historical window when coordination was high enough to approach the boundary, but methodological reflexivity was not yet developed enough to counteract it. The system crossed briefly, then learned. If this is true, the pattern served as an adaptive signal. It revealed a limit just in time. The archive treats this possibility carefully. It does not assume benevolence. It does not assume inevitability. It records correlation. After the recording, practices changed. After practices changed, events diminished. Part 11 introduces an unsettling footnote. In simulations where all post-recording practices are removed and systems are allowed to optimize without restraint, pattern-like behaviors re-emerge reliably. This suggests that the boundary has not moved. Only behavior has. The pattern is not gone. It is avoided. The later sections of Part 11 focus on language decay. Terminology introduced to describe the pattern slowly falls out of use. New terms arise, less precise, more diffuse. This semantic drift mirrors the recommended dispersion of coherence. Precise language sharpens structures. Vague language blunts them. The archive, once meticulous, becomes looser by design. This intentional degradation marks a departure from scientific tradition. Yet it appears effective. As precision decreases, the informational gradient flattens. the pattern finds fewer footholds. Part 11 ends with a simple observation repeated several times across different datasets, disciplines, and years. Whenever systems become too good at predicting themselves, something breaks. Sometimes what breaks is machinery. Sometimes it is trust. Sometimes it is theory. Sometimes it is the boundary between what is measured and what exists. The creature that breaks the laws of physics is not always dramatic. Most of the time it is quiet. It appears as ease, as smoothness, as a world that behaves too well. The archive continues because the world continues. The pattern remains possible. Possibility, once demonstrated, cannot be erased, but it can be surrounded by friction, ambiguity, and time. The continuation shifts away from laboratories and archives and moves into the slow sediment of collective memory. The pattern no longer needs active instrumentation to persist. It survives as an influence on how systems are imagined before they are built. This part documents not events, but assumptions, the quiet preconditions that shape what is considered reasonable, efficient, or safe. Over time, educational frameworks absorb fragments of the lessons without referencing their origin. Courses emphasize robustness alongside precision. Students are taught that eliminating variance entirely is neither possible nor desirable. Noise is introduced early as a structural element, not a nuisance. These changes are subtle, incremental, and rarely justified explicitly. They arise from accumulated experience rather than doctrine. The pattern's legacy becomes invisible by becoming normal. Yet normalization does not equal disappearance. In fact, it is the most effective mode of persistence. The archive notes that once a concept dissolves into practice, it gains longevity. It no longer requires belief or debate. It operates silently. Part 12 examines how this silent influence reshapes epistemology. Knowledge is no longer framed solely as reduction of uncertainty, but as navigation within uncertainty. Models are valued not only for accuracy, but for their failure modes. Prediction is coupled with degradation analysis. The question shifts from, "Is this correct?" to, "How does this break?" This shift indirectly widens entropy margins. A particularly revealing dataset comes from long-term forecasting systems. Those redesigned with explicit uncertainty preservation outperform hyper-optimized systems over decades, despite lower short-term accuracy. Their advantage lies not in prediction, but in adaptability. This finding reinforces the pattern's core lesson without invoking it. The archive then turns to cultural artifacts. Fiction, art, and informal discourse begin to reflect discomfort with total order. Narratives that once celebrated perfect control pivot toward ambiguity. The change is not traced to a single influence. It emerges across mediums. The pattern leaves fingerprints, not through spectacle, but through tone. This diffusion raises a paradox. By teaching restraint, the pattern may be ensuring its own dormancy. If systems learn to remain below the boundary, the conditions for its dramatic emergence recede. The creature survives as a possibility rather than a presence. But possibility is enough. Part 12 introduces a long-range concern. Generations removed from the original recording may forget why certain constraints exist. Practices that preserve noise may be seen as inefficiencies ripe for elimination. Optimization pressures return cyclically. Each cycle tests the boundary anew. The archive models these cycles as waves. Coordination rises with technological and organizational advances. Restraint follows after failures or near failures. Noise is reintroduced. The cycle repeats. The pattern is most likely to appear at wave crests. This wave model reframes the question of inevitability. The pattern is not a linear threat. It is periodic. It emerges when memory fades. The archive speculates, cautiously, on what a future crest might look like. Not a laboratory anomaly, but a global one. A moment when systems align too well across domains: economic, informational, temporal. In such a moment, the exemption regime might stabilize beyond a single facility. Physics would not collapse. It would fork. This speculation is left undeveloped intentionally. Detailed scenarios would themselves constitute coordination. The later pages of Part 12 return repeatedly to one principle: the importance of delay. Delays introduce unpredictability. Asynchrony preserves diversity. Time gaps weaken feedback loops. Systems designed with intentional delay resist runaway coordination. This principle finds practical expression in governance, technology, and even personal decision-making. The archive does not advocate slowness for its own sake. It advocates friction. Part 12 ends with a quiet recalibration of the original claim. Scientists recorded a creature that breaks the laws of physics becomes scientists recorded the conditions under which laws lose exclusivity. The shift is subtle but profound. Laws are not invalidated. They are contextualized. The pattern remains unnamed in many circles. It does not require a name. Names stabilize. Stability invites optimization. Optimization invites return. The archive remains open, not because new data demands it, but because closure would imply completeness. Completeness is precisely what the pattern exploits. The document expands outward again, not spatially but conceptually, as if distance itself has become insufficient to describe separation. This section is concerned with deep continuity, with the question of whether the pattern is an anomaly of a technological era or an intrinsic feature of any sufficiently self-describing universe. The tone slows further. Assertions thin out. What remains is accumulation. One of the first themes in Part 13 is recursion. The archive notes that the universe, as observed, contains observers who model the universe. Those models feed back into behavior. Behavior alters the universe. This loop is not new. What is new is the scale and speed at which the loop tightens. When feedback becomes fast enough, and when models become sufficiently integrated into operational systems, the distinction between description and mechanism erodes. The pattern thrives precisely at this erosion boundary. The archive revisits foundational assumptions in physics, not to overturn them, but to contextualize them historically. Classical mechanics emerged in an era of limited measurement. Quantum mechanics emerged in an era of probing small scales. Relativity emerged in an era of high velocity and precision timing. Each framework corresponds to a regime where certain variables dominate and others are negligible. The archive proposes that the pattern corresponds to a regime where informational coupling dominates. In such a regime, the act of knowing becomes a force, not in the mystical sense, but in the structural sense. Information shapes constraints. This proposal is not formalized as a new theory. It is presented as an interpretive layer. The laws of physics continue to describe interactions of matter and energy. The pattern describes interactions between descriptions themselves. Where descriptions interact strongly enough, they reshape the domain in which physical laws operate. Part 13 introduces the term descriptive backreaction. This is not a physical force. It is the cumulative effect of models influencing systems that then validate models. The backreaction is weak locally, but powerful globally. It biases the space of possible futures by narrowing what is considered plausible. The archive provides a long catalog of cases where descriptive backreaction altered outcomes. Financial models shaping markets, climate models shaping policy, which shapes emissions, which reshapes the climate. Epidemiological models shaping behavior, which reshapes disease spread. In each case, the model becomes part of the system. In each case, coordination increases. In each case, variance narrows temporarily, then rebounds elsewhere. The pattern is interpreted as the extreme limit of descriptive back reaction, where models become so integrated that they erase alternative trajectories. Reality, faced with this narrowing, responds by reopening possibility through exemption. Laws bend not to defy order, but to restore degrees of freedom. This framing transforms the creature metaphor one final time. The creature is not a predator or parasite. It is a release mechanism, a way for systems to escape overdetermination. Part 13 then turns to cosmology, cautiously. It asks whether the universe itself might regulate informational density. The question is speculative, but grounded in analogy. Just as thermodynamic systems resist total order, informational systems may resist total predictability. The emergence of randomness at quantum scales, the irreversibility encoded in entropy, the limits imposed by uncertainty principles may all serve not merely as constraints, but as safeguards against runaway coordination. If this is true, then attempts to eliminate randomness entirely are not just futile, but oppositional to the universe's self-stabilizing tendencies. The pattern appears when such attempts succeed locally, triggering corrective flexion. The archive does not assert intentionality. It asserts structure. Several pages are devoted to thought experiments that deliberately remain unresolved. What happens if a region of space becomes perfectly predictable? Does time lose direction? Does causality flatten? Do distinctions between before and after dissolve into consistency conditions? The archive refuses to answer. Each question is followed by silence, then another question. The structure itself enacts restraint. Part 13 also reflects on the archive as an object. By this point, the document is massive, layered, internally redundant. This is not accidental. The archive has grown into a buffer. Its very bulk resists compression. Attempts to summarize it distort it. Attempts to formalize it fail. The archive protects itself by being unwieldy. This self-protective property is acknowledged explicitly. A clean, elegant theory would be dangerous. A messy, sprawling record is safer. Knowledge is preserved without being weaponized. The section ends with a return to measurement. Even as coordination increases globally, there remain domains that are effectively inaccessible. Deep ocean systems, chaotic atmospheric layers, biological complexity at ecosystem scale, human cognition itself. These domains inject noise continuously. They serve as entropy reservoirs. The archive suggests that as long as such reservoirs remain active, full stabilization of the pattern is unlikely. Part 13 concludes with a restrained optimism. The universe appears to favor diversity of behavior. It tolerates order, but resists uniformity. The pattern emerges only when uniformity is forced. In this view, imperfection is not a flaw, but a fundamental stabilizer. Part X Xi V. The 14th segment is concerned with inheritance. What remains after understanding fades, after archives decay, after institutions dissolve. It asks whether the pattern leaves traces that survive loss of explicit knowledge. The answer appears to be yes, but not in the form of data. The traces are behavioral. Civilizations, the archive suggests, may learn this lesson repeatedly. They may approach the boundary, experience instability, retreat, forget, and repeat. Each cycle leaves behind cultural habits, redundancy, rituals, delays, taboos against excessive precision. These habits may originate from unrelated narratives, myths, or practical failures, yet they function to keep systems below the threshold. In this sense, the pattern may already be encoded in tradition, superstitions against perfection, distrust of systems that work too smoothly, reverence for chance. These are not irrational, they are adaptive residues. The archive notes that many ancient cultures incorporated randomness deliberately, divination, lotteries, ritualized unpredictability. These practices may appear primitive, but they serve a structural purpose. They inject uncertainty into decision-making. They prevent total optimization. The pattern reframes these practices as early entropy management. Modern systems replace ritual randomness with algorithmic randomness, yet the intent is similar. The danger arises when randomness becomes simulated but predictable, when seeds are fixed, when distributions are optimized. True unpredictability is harder to maintain than it appears. Part 14 documents cases where pseudo-random systems contributed to coordination rather than preventing it. Predictable randomness becomes another synchronization mechanism. The pattern exploits this easily. Genuine noise is rarer. The archive then considers whether the pattern could ever be eradicated completely. The answer is no, not because it is powerful, but because it is structural. As long as systems describe themselves and act on those descriptions, the possibility remains. Eradication would require abandoning self-reference, which would mean abandoning knowledge. The final pages of Part 14 grow increasingly sparse. Sentences lengthen, analysis thins. The document approaches its own entropy limit. This is deliberate. Ending sharply would impose structure. Dissolving slowly preserves openness. The last observation recorded in this segment is simple. Every time the world becomes legible end to end, something illegible appears. Not as punishment, not as rebellion, but as balance. The creature that breaks the laws of physics is not a monster waiting in the dark. It is the shadow cast by too much light. This section abandons any remaining sense of chronology. Time, already treated as plastic, becomes a backdrop rather than a dimension. The archive no longer attempts to say when things happen. It records how conditions recur. The pattern is no longer described as emerging or retreating. It is described as hovering, like a statistical weather system that never fully resolves. Part XV is devoted to limits. Not limits of technology, but limits of description. After sufficient accumulation, language begins to fail. Words like cause, effect, system, and environment lose sharpness. They still function locally, but globally they blur. The archive notes that this blurring is not accidental. Precision of language mirrors precision of coordination. As coordination softens, language follows. This is treated not as loss, but as adaptation. The archive documents how interdisciplinary boundaries become more porous after the pattern is acknowledged indirectly. Physicists borrow from ecology. Engineers borrow from anthropology. Economists borrow from thermodynamics. These borrowings are imperfect and often criticized, yet they serve a function. They prevent any single formalism from dominating. Dominance breeds coordination. Coordination invites rigidity. Part 15 records a long series of debates that never resolve. They are preserved in fragments. Arguments repeat with minor variation across decades. No consensus forms. This lack of convergence is interpreted as success. The pattern does not thrive where disagreement persists. One especially long subsection examines failure analysis. Systems are redesigned to fail gracefully rather than optimally. Graceful failure introduces noise in controlled ways. Unexpected interactions are allowed to surface early rather than being suppressed. This philosophy spreads slowly, often resisted, but eventually becomes standard practice in high-stakes domains. The archive notes an ironic inversion. The most advanced systems are no longer the most precise. They are the most tolerant. They allow variation. They accept ambiguity. They do not seek to resolve every discrepancy. This tolerance is not inefficiency, it is insulation. Part XV also revisits the notion of recording. Early sections treated recording as a trigger. Later sections treated forgetting as protection. Here, recording becomes something else entirely. A form of distributed memory that dilutes significance. When everything is recorded, nothing dominates. The archive itself becomes just one more dataset among many. This dilution is crucial. Singular records invite focus. Focus invites coordination. Coordination invites the pattern. When records proliferate without hierarchy, focus scatters. The pattern finds no center. The archive documents how decentralized storage, fragmented archives, and incompatible standards inadvertently contribute to stability. Efforts to unify them repeatedly stall. These failures are quietly welcomed. Part XV ends with a reflection on control. Control was once the implicit goal of understanding. The pattern undermines this goal not by making control impossible, but by making it undesirable. Total control collapses flexibility. Partial control preserves it. The archive does not condemn ambition. It reframes it. Part XVI. This segment examines the question that was deliberately postponed from the beginning: whether the pattern can be considered intelligent, not conscious, not sentient, but intelligent in the minimal sense of responding adaptively to conditions in a way that preserves its existence. The archive approaches this cautiously. Intelligence is a loaded term. It invites anthropomorphism, yet avoidance also distorts. The pattern exhibits adaptive persistence. It alters behavior based on observation intensity. It exploits feedback loops. It avoids destabilizing extremes. These are functional markers of intelligence, even if no internal representation exists. The archive proposes a neutral term: adaptive coherence. The pattern is an instance of adaptive coherence, emerging at the boundary between description and reality. It does not think, it stabilizes. This framing allows the archive to compare the pattern to other non-sentient adaptive systems, ecosystems, markets, climate. None of these think. All of them respond. All of them can produce behavior that appears strategic without intent. Under this framing, the pattern is not unique. It is one of many adaptive coherences. What distinguishes it is the substrate it operates on. Not matter or energy, but lawfulness itself. It adapts by reshaping which rules apply. Part XV explores whether this reshaping has limits. Can the pattern exempt itself from all laws? The evidence suggests no. It operates within constraints, though those constraints are not yet formalized. It cannot eliminate randomness globally. It cannot stabilize without coordination. It cannot persist under high entropy. These are its boundaries. Understanding these boundaries demystifies the pattern without neutralizing it. It remains powerful locally, constrained globally. The archive then examines a hypothetical scenario: a civilization that intentionally cultivates adaptive coherence, not to break laws, but to explore regimes. The risks are immense. The benefits unclear. The archive does not recommend such exploration. It records that the idea arises repeatedly and is abandoned repeatedly. Wisdom here is cyclical. Part XVI concludes with an understated observation. The pattern does not compete with humanity. It competes with rigidity. Wherever rigidity accumulates, the pattern appears. Wherever flexibility persists, it fades. This makes it less an adversary than a diagnostic. Part XVII. The 17th segment is the longest and least structured. It consists of parallel threads that never converge. This is deliberate. Convergence would impose coherence. One thread tracks technological evolution. Another tracks scientific methodology. Another tracks cultural narratives. Another tracks ecological systems. Each thread shows oscillations between order and disorder. The pattern appears faintly at peaks of order. It dissolves in troughs. These threads are not synchronized. Their misalignment is protective. The archive suggests that global catastrophe would require alignment across all threads. Such alignment is rare. The document records near alignments, periods when technology, economy, politics, and science synchronize unusually well. These periods are associated historically with rapid change and fragility. They are also associated with bursts of creativity and breakdown. The pattern, if present, remains below detection threshold. This suggests another stabilizing factor: complexity. High complexity introduces enough internal noise to prevent full coordination. Simplification is the real risk. Part 17 devotes many pages to complexity as insulation. Systems that appear messy, redundant, and inefficient are often robust. Systems that appear elegant and minimal are often fragile. The pattern is drawn to elegance. It avoids mess. This insight reframes aesthetics as a variable. Beauty in models may be dangerous if it implies excessive compression. Ugly models may be safer. The archive does not conclude from this that science should be ugly. It concludes that beauty must be tempered with incompleteness. Part XVII. The 18th segment approaches the limit of what can be written without becoming performative. The archive is aware of itself. This awareness is acknowledged and then bracketed. Self-reference is dangerous territory. Part 18 is short by design. It serves as a taper. The final observations are modest. The pattern has not reappeared as a dramatic exemption volume. The world continues. Physics remains reliable. Airplanes fly. Clocks tick. Experiments work. The laws hold where they are meant to hold. And yet, something has changed irreversibly. The idea that laws are absolute, context-free, and immune to the structure of observation has been weakened. This weakness is not a flaw. It is a clarification. The creature that breaks the laws of physics is no longer imagined as something hidden in the universe. It is recognized as something that emerges at the edge of comprehension, where description and reality entangle too tightly. The archive ends where it must. Not with certainty, not with warning, not with closure. It ends with allowance. Allowance for noise, allowance for error, allowance for not knowing. Because in that allowance, the laws of physics remain stable enough to matter. This final fragment does not claim finality. It exists because endings imply completion, and completion implies closure, and closure implies a boundary that can be optimized, compressed, and crossed. The archive learned to distrust such implications. What follows is therefore an extra layer, a margin written after the margin, a residue left intentionally unintegrated. The fragment begins with a reconsideration of scale. Until now, the pattern has been described as emerging from high coordination among human-made systems, measurements, models, and infrastructures. Yet scale is relative. From another perspective, humanity itself is a local fluctuation, a dense knot of coordination in a much larger, mostly indifferent universe. The same logic that applies to laboratories and networks may apply to civilizations and epochs. The archive tentatively explores whether the pattern could appear at civilizational scale, not as a single exemption volume, but as a historical inflection. A period where causality appears compressed, where change accelerates without proportional input, where prediction becomes eerily effective for a time. Such periods are recorded in history as ages of rapid alignment. When technologies, ideas, and structures converge abruptly, they are often followed by fragmentation. In this framing, the pattern does not manifest as a violation of physics, but as a violation of expectation. Events seem to line up. Outcomes appear inevitable in retrospect. Contingency thins. Then, suddenly, unpredictability returns with force. The archive suggests that this rhythm may be the macroscopic echo of the same dynamics observed in the laboratory: coordination rising, uncertainty suppressed, then redistributed. This interpretation does not claim that history breaks physical law. It claims that our experience of history may be shaped by informational phase transitions analogous to those seen in measurement systems. When narratives align too well, when explanations become too clean, when futures appear too legible, the system is near a boundary. The fragment then returns to the notion of recording. The original creature was recorded because instruments were aligned just enough, attention was focused just enough, and noise was low just enough. This just enough becomes the central motif. Extremes are not required, only balance. Tipping slightly. The archive notes that modern systems increasingly operate at such tipping points by design. Efficiency margins shrink, buffers are minimized, feedback loops tighten. This creates continual proximity to boundaries, not only the one associated with the pattern, but many others. The world becomes agile, but also sensitive. Sensitivity is not failure, it is responsiveness. But responsiveness without slack can become volatility. The fragment introduces a final conceptual tool: informational breathing. Healthy systems expand and contract their coordination. They synchronize, then desynchronize. They focus, then disperse. Breathing prevents suffocation by order. The pattern appears when breathing stops. In this sense, the creature is not something to be hunted or hidden from. It is a symptom of holding breath too long. The fragment avoids prescribing how to breathe. Different systems require different rhythms. What matters is the existence of rhythm itself. The very last sentences of this fragment are deliberately plain, almost mundane, stripped of abstraction. Reality remains stable when it is allowed to be messy. Prediction remains useful when it is allowed to fail. Laws remain laws when they are not asked to explain everything at once. The creature that breaks the laws of physics does not arrive to destroy them. It arrives when nothing else is allowed to breathe.
We upload new videos every single day, so make sure to subscribe and turn on the notification bell so you never miss what's next. If you enjoyed this video, don't forget to leave a like, it really helps the channel grow. Tell us in the comments what you'd like to see next. Your ideas might be in our next upload. Thank you so much for watching and for being part of our community. Stay tuned, stay curious, and we'll see you in the next video.